Hello, stats class. This is lesson 5.2b. Remember 5.2a was probability rules. I thought about calling this more probability rules, but I decided to go with probability rules again because it's more fun. So, couple reminders, actually just one reminder of what we did in 5.2a. We learned the addition rule that says if you have the probability of A, I'll use the symbol, which remember that symbol means or. Probability of A or B, and we found those probabilities by adding the probability of A plus the probability of B, but that only works in one specific situation if A and B are disjoint, which is also called mutually exclusive, which also means there's no overlap between them. So if you can't have both at the same time, then you can just add them together. And I have to say that that's actually the more unusual situation when you have disjoint events. It's more common for there to be an overlap. And so that's what today's lesson is about. It's about what if there is an overlap. And we saw some of this happening in the warm-up, not disjoint. Whoa, I just totally spelled that wrong. Disjoint events. Non-disjoint events is what we're talking about today. So we saw that with the backpacks and the wallets in the warm-up, where the backpacks, you could have a backpack and a wallet, or you could have one or the other or neither. And so we're going to switch contexts and talk about male versus female. And I'm making a Venn diagram like we talked about in the warm-up, and whether your ears are pierced or not. Now, if you were to assume that no males have pierced ears, you would probably be wrong, depending on the population. There are some men with pierced ears, not as many as women, but there's going to be some overlap. And so here is results of a survey of a whole bunch of college students. And as you might guess, there are lots of people in this survey, so I'm just going to give you the numbers in the Venn diagram. There were 19 guys with pierced ears. There were 71 guys without pierced ears. There were 84. This is women with pierced ears and women without pierced ears down there in the neither category. So that's the numbers we have to work with. And there's a lot of questions I could ask you with this. We're going to start with the easy ones. I could ask you to find the probability of being male. And if you add up these four numbers, there were 178 people surveyed. I think I'll write that over here. N is 178. That is the total who were surveyed. All right, so the probability of being male would not just be the 71. It would be the 71 and the 19 put together. And I'm going to use yellow to highlight that because, by the way, if you have highlighters, you might want to do some highlighting with me today. I'm going to make these notes very colorful. So the 71 and the 19 put together is 90 men in this survey out of 178. And in case you need me to show work, that came from 71 plus 19. And that came from 71 plus 19 plus 84 plus 4. 178 people in the survey. And we could reduce that or make it a percent or whatever. That's not the important part. The important part is, can you find the correct number for the top and the correct number for the bottom? And that came from this whole circle divided by the whole thing. So that is one of the possible probabilities I could ask you for. 90 out of 178. Probability of pierced ears, I'm going to call that P. Would be all the people with pierced ears out of 178. So for that, I want to add these two groups together, which is the 84 and the 19. I need a different color for that, so I'm using pink. I don't know if that pink is too strong to make it. It should be that the 19 still looks a little bit yellow. Let's make that more obvious by making shading it with orange. That both section in the middle is important, so I'm making it orange. And the 84 plus 19 comes out to 103, and that's how many people out of 178 had pierced ears. So now here's where I said you'd be making a mistake if you assumed there were no men with pierced ears. if I want to know the probability of one or the other, probability of male or pierced ears, I would not just add these together. It would not work. And the reason it would not work is that the probability of male and pierced ears, which it could also be written like this, and is the upside down U, is not 0 in this situation because there is an overlap. It is possible to find a guy with pierced ears. That's what makes this not disjoint. And in some situations, you wouldn't know it's possible until you do your survey. Maybe some populations would have no guys with pierced ears. I don't know. But we're not going to assume that. So the probability of both is the same as the probability of male and pierced ears. That's that orange section in the middle. That's the 19 out of 178. It's not 0. So because it's not 0, we're going to have to work with that. So back to what we were doing up here, probability of male or pierced ears. There are 2 ways to calculate this. Neither one of them is the same as adding 90 plus 103. So I'm just going to tell you that. Don't do that. There's 2 ways to do it. You could look at these 3 pieces put together, and you could go 71 plus 19 plus 84 and divide it all by 178. And we already know 71 plus 19 is 90. That's the males. And then we'd have to add these 84 females who have pierced ears. So 90 plus 84 is 174. It's actually almost all of this particular population is male or pierced ears. We're only leaving out 4 women who don't have pierced ears, and that's all we're leaving out. That is one way to do it, is to add these 3 pieces together, and that's basically what this U means, the union of these 2 groups combined. So those 2 groups plus the overlap, that's one way to do it. Or, remember this also means or, you could also do the 90 and the 103 and then realize that you've counted some people twice. So if you start out doing 90 plus 103 out of 178, then what you've got is you've got the 90, which is the yellow. In fact, maybe I should do this also. And you've got the 103, which is the pink. And the thing is that these 19 people, if you're doing it this method, you've counted them twice. You counted the 19 as part of the 90, and you counted the 19 again as part of the 103. And so in order to avoid that problem of counting them twice, you subtract the 19. And I could have done that as 3 separate fractions. In fact, I could have done this as 3 separate fractions also. It's basically 90 over 108 plus 103 over 178. These 2 fractions added together minus 19 over 178, which is this fraction. So you could put it as 3 fractions, or you could combine them. Either way, you get the 174 out of 178. And I want to make sure you know that this 19 is the both. We're subtracting the people that got counted twice. So we need to subtract them so that we don't count them twice, or subtract the overlap. And that's kind of a common sense thing, but the Venn diagram makes it more obvious. And I want to point out that the math or is different than the English or. If I tell you that you can have a cookie or you can have a donut, then I'm implying that you can only have one or the other and not both. The math or implies both. Or maybe I should say includes both. So when I say the probability of being male or having pierced ears, I'm saying being male or both or having pierced ears. I'm implying all of that, or including all of that in my request for information. So that is, this right here is the official addition rule that works for everything, not just disjoint events. You add them together, and then you have to remember to subtract the overlap. So let's write that down as the official general addition rule. The first addition rule that we learned up there is the specific addition rule that only works for disjoint. So this is one of the really important rules in probability. For any events A and B, the probability of A or B, oops, that's a U without the tail, don't forget that means or, is the same as the probability of A plus the probability of B. If you stop there, you're assuming it's disjoint, but I don't want to assume it's disjoint, so I don't want to use that formula, which is what I just wrote down. I want to remember that that extra piece that's overlapping needs to be subtracted, and that's the probability of A and B, or in other words, A plus B minus both. This is and that is the general addition rule that works for all events. Now, I want to point out to you that if they happen to be disjoint, this still works. Because if they happen to be disjoint, then this piece is 0, and you'd just be subtracting 0. So that's not a problem. If they're disjoint, then the overlap is 0. That's the definition of disjoint. And so it's not a problem to use this one for everything. In fact, I almost didn't teach you the other one. I almost said, well, let's just not even talk about the other one, except that the other one is very common sense, like that it makes sense that you would add the pieces together. If the pieces are disjoint, like these 3 pieces, you can add them together. If they're not disjoint because they're overlapping, you have to subtract the overlap. So that is the general addition rule. And we need one more example of it, I think. So let's switch to a different context. Let's say we have people reading newspapers, and 40% of my people surveyed read USA Today, and 25% read the New York Times. And of course, it is possible that some people read both. You got to keep that in mind. This is not a disjoint thing. So I'm going to say there's 5% of my population that read both. And that 5% would be included in the 40%, and it would be included in the 25%. So I will do this 3 different ways. I'm going to do it with the formula and with the table and with the Venn diagram, just to show you all of those things together. So we're going to say probability of U and N, USA Today and New York Times is 5%. This is the probability of U and the probability of N. We could write that if we wanted to. And the probability of N. I'm just giving them letters. So that's what I've got, the given information. If I want to find the probability of U union N, which is U or N, the probability of one or the other or both, or I could say this is the probability of at least one. That's what that symbol means. Then I do the formula, and I have the numbers. This is easier than what we did with the backpacks and wallets because you weren't given these 2 numbers. Maybe you were. Actually, I can't remember. It doesn't matter. So we would basically do the probability of U plus the probability of N minus the probability of both. And so that is the 40% plus the 25% minus the 5%. And let's do some more highlighting. So this one plus this one minus the overlap. All right, and then visualization is always important in math. So if you make it into a table or a Venn diagram, it will help you understand it better. So here it is in picture form. USA Today, New York Times. This represents everybody in the survey. We have 5% in the middle. Do not put 40 here. So the 40 is this whole circle, and that means we have to do 40 minus 5 to get this piece, and I wanted to make sure I talked about that. This number comes from the 40 minus the 5, and it's the people who read only the USA Today and not the New York Times, because this has to add up to 40. This piece right here is not 25 because the whole circle is 25, so I would subtract the 5 and get 20, not 25. So this came from 25 minus 5, and then I could figure out how many are on the outside by saying, oh, I didn't finish this, did I? 40 and 25 is 65 minus 5 is 60%. That's all three of these put together. Notice I also could have done 35 plus 5 plus 20 to get this, and it would have worked. So there's two ways to calculate that. You can do the whole thing and minus the overlap, or you can do the part, add them together. And by the way, if this is 60%, this outside number is 40%. It's the complement rule, so 100% minus 60%. So there's the Venn diagram version. This middle piece is the both. So this is the and symbol, U and N, both. This is just the USA Today. This is just the New York Times. This is the neither. All right, and then we also could put it in a two-way table, and I actually like those better sometimes. It depends on my mood, I guess. The reason I like two-way tables better is there's a place to write the 40 and the 25. So I'm going to do it with the official symbols to get you more used to that. This is USA Today. This is not USA Today. This is total. This is New York Times. This is not New York Times. This is total. And so we're going to put the numbers in. And the thing I like better about two-way tables is the 40% has a place to be written down. It's the total USA Today people, 40%. The total New York Times people, that goes in this total spot. And then the 5% goes here, and you should be able to fill in the rest from that information. So